Hi everyone. Today we are going to discuss force on a charge because of multiple charges. In the last class we have discussed how to write vector formula of Coulomb's law. I think you have a clear idea about the force acting on a charge because of another charge or the force of interaction between the charges. You have to know the equations, then only this session will be useful for you. Objective of this session is to learn about forces between multiple charges. So here we are going to discuss force on a charge because of multiple charges. Here we are going to consider a 3-charge system. In the system we have 3 charges. Because of these 3 charges, what is the total force acting on a particular charge? That we are going to discuss here. We are going to consider one charge among these 3 charges and we are going to study that one charge. Okay. Before starting this session, let us revise something. Previous knowledge. Coulomb's law, the force of interaction between 2 charges is directly proportional to product of the charges and inversely proportional to square of distance between them. Equation 1 by 4 pi epsilon 0 q1 q2 by r square equal to f. Okay, if we are considering the unit vector, in the vector formula it will be vector f equal to 1 by 4 pi epsilon 0 q1 q2 divided by vector r whole square into unit vector r. R is the distance between these 2 charges. Charges are q1 and q2. These things we have discussed in the previous classes. Now we can discuss the force because of the multiple charges. Here we are considering a system. It is x and y axis. It is a center O. And we are considering a system of charge. This system is having 3 charges. 1, 2, 3. There are 3 charges, q1, q2 and q3. So we are considering a system. In this system there are 3 charges, q1, q2 and q3. We are going to study the force acting on q1 because of other 2 charges, because of q2 and q3. Some forces are acting on q1 because of q2 and q3. That we are going to study here. So here we have the position vectors. The position vector of q1 is r1, position vector of q2 is r2, position vector of q3 is r3. Okay, so we have this position vector and distance between q1 and q2, it is r12. Distance between q1 and q3, it is r13. The displacement to q1 from q2 is r12. The displacement to q1 from q3 is r13. Okay, now we are going to study the forces. Forces on q1. Force on q1. Force on q1, it is because of 2 charges. There are 2 forces. q2 is exerting a force on q1, q3 is exerting a force on q1. So when we are considering q1, we need to add these 2 forces to find the total force, right? On q1, q2 is exerting a force, q3 is also exerting a force on q1. So we need to find the total force here. So first we are finding force on q1 because of q2, that is F12. Force on q1 by q2. First we are considering force on q1 by q2. Okay, what will be the equation for that? F12 equal to 1 by 4 pi epsilon 0, it's common, right? It's part of equation. q1 q2 by the displacement is r12. The vector is r12 here. So vector r12 square into unit vector r12. Similarly, we can find force on q1 by q3. It will be F13. F13 will be equal to 1 by 4 pi epsilon 0 q1 q2. Instead of this q1 q2, it will be q1 q3 by r13 vector r13 modulus square into unit vector r13. Right? So there are 2 forces. Now we are going to add these 2 forces. Now we have 2 forces. F12 equal to 1 by 4 pi epsilon 0 q1 q2 by vector r12 square into unit vector r12, right? Similarly, F13 equal to 1 by 4 pi epsilon 0 q1 q3 by vector r13 square into unit vector r13. How to find the total force? Total force equal to F12 plus F13. Vector F12 plus vector F13. Here you can see that it is vector F12 plus vector F13. We are finding the total force acting on q1. Okay, so vector F equal to, what is the equation for this F12? Here we have the equation. Okay, so we can write it 1 by 4 pi epsilon 0 q1 q2 by modulus of vector r12 whole square into vector r12. So this part is over. Okay, then second part f13. F13 we have the equation. This is the equation for f13. So we can write that plus 1 by 4 pi epsilon 0 q1 q3 by vector r13 square into unit vector r13. Here you can see that this 1 by 4 pi epsilon 0, this 1 by 4 pi epsilon 0, both are common. 1 by 4 pi epsilon 0 and 1 by 4 pi epsilon 0 both are common, so we can take it out. So it will be f equal to 1 by 4 pi epsilon 0 bracket. Inside the bracket, now the terms are q1 q2 by vector r12 square into unit vector r12 plus q1 q3 by vector r13 square into unit vector r13 with modulus. Okay, modulus of vector r13 square into unit vector r13. So we have this equation now. This is the total force when we are considering a 3 charge system, and q2 q3, these 2 charges are exerting a force on q1. So this is the equation for that 3 charge system. Just imagine there are 4 charges. 4 charges means there is one more charge, that is q4. So there is one more charge q4. So we are considering 4 charges system. So what would be the equation? Just observe the pattern of this equation. 1 by 4 pi epsilon 0, it is common, it is outside, it won't be changing. q1 q2 r12 vector r12, q1 q3 r13 vector r13. So if there is another charge q4, what will be the equation? What will be the equation for force? We can write it very simply, right? F equal to 1 by 4 pi epsilon 0 bracket q1 q2 by vector r12 modulus square into unit vector r12 plus q1 q3 by vector r13 square modulus square into vector r13 plus the fourth charge, that is q4. It will be q1 q4 by vector r14 square into r14 unit vector. So this is a new term which is came in because of the fourth charge. If there is a fifth charge, it will be q1 q5. Okay, so if there are n charges, it is an n charge system. There are more number of charges, so it is n charge system. So these n charges are going to apply a force on q1, right? So what would be the equation for that? You need to continue up to n. So we can write the equation. Here it is q1 q4. The last term is q1 q4 because there are 4 charges. If there are n charges, the last term will be q1 qn. Okay, so equation will be, if there are n number of charges, f equal to 1 by 4 pi epsilon 0, that is common, q1 q2 by r12, q1 q2 by vector r12 modulus square into unit vector r12 plus q1 q3 by modulus of vector r13 square into unit vector r13 plus etc plus q1 qn, that is important. Okay, it is q1 qn divided by modulus of vector r1n square into unit vector r1n. That will be the equation for force acting on a particular charge because of n number of charges. So that's all for today. In the next class we are going to discuss electric field. Thanks for watching.